this video, we're going to be going over notes 8.2, and we're going to be looking at graphing the reciprocal and rational functions. So really we're graphing rational functions, and the parent function is called the reciprocal function. So let's just do a quick refresher. What is a rational function? All right, well, it is a function in the form of, so it's a function, we'll call it f of x, and it's in the form of some other polynomial function divided by another polynomial function. So p of x and q of x are just polynomials, all right? And because it's a quotient or a fraction, you just have to remember that the bottom can never equal 0. So we're going to say, and q of x cannot equal 0. Okay, so that's what a rational function is. It's just a fraction where you have, usually have x's on the top and the bottom. All right, so the parent function, all right, because remember when we're graphing, which is what we're starting today, we typically look at a parent function. What is the most basic form of the function, and what does its graph look like? Okay, so the parent function is called the reciprocal function because it looks like the reciprocal of x, because it's 1 over x. Okay, so that is the parent function for all rational functions. And here's what it looks like. Okay, it actually has two parts to it. Okay, and I'm just sketching, right? But it's got a curve, or maybe you want to call it like a swoosh or something, in the first quadrant. And then it has another one in the third quadrant. Okay, so that's what the graph looks like. If you were to type it into Desmos, which I have pulled up right here, you can actually type it in, f of x equals 1 divided by x. Okay, you will see that you have these two curves, and you can zoom out as far as you want to. They never turn and curve any other way. They just kind of go along. They get really, really close to the x and the y axis. All right, but you'll see they never, ever, ever cross, all right, that x and y axis. Okay, so that's going to be important when we talk about the other characteristics. Okay, now we just said that they never, ever, ever cross, at least for the parent function, the x and the y axis. So they have these things that we call asymptotes. And when you're drawing the graph by hand, all right, you'll often draw them as just little dotted lines. Okay, but if you look back at Desmos, you actually could not see them because, you can look right here, an asymptote is just an invisible line that the graph never crosses or touches. Okay, and these asymptotes are technically they're invisible lines, so they actually have equations. All right, and so if I want to know what the vertical asymptote is, that means I'm asking you for the equation of this invisible vertical line. Well, since it's vertical, that's x equals, and it goes through x equals 0. And so that is the equation of the vertical asymptote. The horizontal asymptote, again, it's invisible, but it's still a line. It's a horizontal line. So the equation of a horizontal line is y equals a number, and that happens to go through 0 on the y-axis. All right, so that's a little introduction to asymptotes. Now, those asymptotes are also necessary. You need to know them in order to figure out the domain and range. Because if the graph cannot cross that asymptote, then that means that the graph doesn't actually equal that number. Okay, so when I do the domain, remember those are your x values, right, from left to right. And you can see, right, this is going to the left forever, but it will never cross this x equals 0. It just kind of, it keeps going down, but it never touches this x equals 0. And then all of a sudden over here, it starts again and keeps going to the right forever. But again, it never touches this asymptote. So the domain is every single number possible except x equals 0. So the quick way to say that is to say that x cannot equal 0. But if I wanted that in interval notation, you would have to actually start at negative infinity, stop at 0, union, and start again at 0 and go to positive infinity. Okay, so this interval means the same thing as this x cannot equal 0 notation. All right, well, the vertical asymptote, and we'll talk more about this later, but the vertical asymptote is directly linked to the domain. Okay, so if you know the vertical asymptote, you'll be able to find the domain. Similarly, let's get a different color, right? Similarly, the horizontal asymptote is linked to the range, all right? Because again, an asymptote is a line you can't cross. So my blue graph here, that touches all the y values below 0, and this blue graph touches all the y values above 0, but I never actually touch 0. And so my range is all the y values except 0. And since it's pretty much, other than the fact that it's a y value instead of an x value, if I wanted to see the interval for that, it would look exactly the same as the other one. Okay, so that's quick and easy, or maybe not easy, but the quickest explanation for the parent function. All right, now what can you do with the parent function? Well, you can use it to help you find transformations. Remember us doing transformations before, where you look at something to see if it shifts up, down, left, right, okay? You can do transformations based on the reciprocal function. So here is how it compares to the reciprocal function. So it's still a function, all right? But it could have a number divided by x minus h, and then it could have another number added or subtracted after it, okay? And if you think about any of the transformations we've done before, we always had an x minus h somewhere in the problem, and we always had a plus k somewhere in the problem, all right? Because those are our up and down or left and right shifts. If you will remember, right, I have to dig deep, all right, h, if it's next to the x, all right, that means that shifts your graph on the x-axis. All right, so that is a horizontal shift, okay? Where if it was a plus a number, that would actually shift the graph to the left. And if it was minus a number, that would shift the graph to the right. Okay? K, the number that's added or subtracted after the entire fraction, that's going to be the shift in your y-axis. So that's going to be a vertical shift. That means up or down. And if you remember anything about up or down, plus means up and minus means down. Okay? Now, other transformations that we've talked about is what happens if there's a negative? Okay, well, if there's a negative, it would show up on top of this fraction, or I guess maybe in front of the entire fraction, right? But the number would be negative. And if that number here, that A, is negative, then the graph is, change colors again, reflected over the x-axis. All right, and then the last transformation that we've talked about in the past is whether the graph stretches or shrinks, okay? And we're vertical stretch or shrink. Well, if A, and I'm only talking about positive, I don't care if it's negative, if A is greater than 1, okay, because the negative means something else. So if the positive A is greater than 1, right, remember that means you're going to have a vertical stretch. And if A is a small number, a fraction perhaps, between 0 and 1, that's when you're going to have a vertical shrink. All right, let me pause just a second. Sorry for my... All right. Okay, so one other thing that you need to understand that you can get directly from an equation like this, excuse me, is where the vertical asymptote will be and where the horizontal asymptote will be. All right, so the vertical asymptote is, let's see, related to the horizontal shift because it has to do with the x value. All right, and so you can find the vertical shift by actually taking x and setting it equal to h. And then you can find the horizontal shift, or excuse me, horizontal asymptote by finding the k value and setting it equal to the y. And we'll talk about that a little bit more when we actually look at some examples. All right, so we're going to look at a couple of examples together, and then we will make our functions a little bit more complicated. All right, so I want to sketch the graph of each reciprocal function. Then I'm going to describe the transformation. I'm going to figure out the asymptotes, and I'm going to look at the domain and range. I'm also going to get some x and y intercepts to help me graph a little bit better, but I'm going to use Desmos to do that. Okay, so here's what I would, well, I don't know. I feel like it might actually be easier to do a lot of this without trying to guess when you look at Desmos. All right, so let's think about our transformations. I have a +3 on the bottom with the x. So that's like an h value. All right, and so I just have to remember that plus means I'm going to shift to the left. And so my first transformation is left 3. Okay, now because I don't have any numbers added or subtracted outside, I don't have a vertical shift. My number on top is 1, so that means it hasn't changed. And so it's not a stretch or shrink, it's not negative, so it's not a reflect. So my only transformation is left 3. And if I move left 3, okay, that means I'm taking what would have been the vertical asymptote at x equals 0, because that's what it is on the parent function, and I'm shifting it to the left 3. So whatever my left and right shift is, that's going to tell me where to put my vertical asymptote. And if I had an up or down shift, that would tell me where to put my horizontal. But since I don't have an up or down shift, the horizontal asymptote is going to stay on y equals 0. All right, now I just need to know what the rest of the graph looks like, and it should look like the parent function, but if I were you, I would actually type it into Desmos to look. All right, so I'm going to come over here to the one I already have typed in, and just put a +3 on the bottom. Okay, and so it still has those 2 curves. All right, but you can, if you want to, you can kind of trace an invisible line here at x equals -3, and you should never actually touch the graph. And then the same thing at y equals 0. So it still has those 2 curves. I can zoom out as far as I want, and it will always be those 2 curves. Okay, and so that's what I'm going to put on my graph. But since it gives it to me, I'm going to actually use some of the points that Desmos gives me. All right, Desmos gives me the y-intercept, and unfortunately, it can't give me an x-intercept because that's an asymptote. All right, so I'm going to come back over here, and I'm going to first say, okay, well, there's none for the x-intercept. The y-intercept was at 0 and 0.333, so that's done. Then I'm going to plot those points, or that point, 0.333. Let's do a different color. Okay, and then I'm going to draw my curve the best I can without touching my lines. But asymptotes mean I get really, really close. I just don't touch it. So that's going to keep going flat, and that's going to keep going straight up. But there was another one over here, just didn't have any intercepts that I could find. All right, so there's your graph. And then I didn't mean to skip these, but for the domain and range, remember we said the vertical and the domain go together. So if the vertical asymptote is x equals -3, then the domain is x cannot equal -3. And for the horizontal asymptote and the range, remember you can pair them up. And so if the horizontal asymptote is y equals 0, the range is y cannot equal 0. You're welcome to do those in interval notation if you would like, but you certainly don't have to. I will show you what those look like real quick. All right, so if I can't equal 3, I go all the way up, or -3, I go all the way up to -3, stop, and then pick back up at -3. And then same thing with the 0. Go to -3, break, or excuse me, go to 0, break, and start over at 0. All right, these mean the same thing. You do not have to do both. All right, I know the video is getting long. I just want to finish this one section. Okay, so real quick, let's talk about the transformations. Well, I've got a negative number on top, so that means that this thing has been or should be reflected over the x-axis. Okay, I do not have, oh, and it's a 4. Well, that's bigger than 1, so that means we have a vertical stretch. And then I look at my x, and there's nothing added or subtracted to it, so I'm not going to shift right or left, but I have a +1 after the whole fraction, and that means I'm going to shift up 1. Okay? Well, when you draw your graph, the main thing that you're shifting are where the asymptotes were, okay? So the vertical asymptote for the parent function is at x equals 0. And if I'm not shifting that right or left, then it's going to stay at x equals 0. So if I don't have a right or left shift, x is going to stay at 0, the asymptote. All right, but the horizontal shift, that's the flat one. All right, well, since my graph is shifting up 1, my horizontal asymptote has to shift up 1. And so then that will be at y equals 1. All right, now I don't even have to graph it to know that the domain is going to be x cannot equal 0, and the range is going to be x cannot equal, or excuse me, y cannot equal 1. So the only other thing I really want to know is where am I going to put my curves, and do I have any x or y intercepts? So I'm going to come over to Desmos, and I'm going to type it in and look at it. All right, so let's see. I'm going to change the top to -4, get rid of the +3 on the bottom, but put the +1 afterwards. Okay, so we've got 2 curves, but look, all right, we've got one in the second quadrant, and then one kind of in the fourth quadrant. And we've got a point right here on 4, 0. That's the y, excuse me, that's the x-intercept. And you can zoom out. We're never going to cross the y-axis because of the asymptote. So the only point you're going to be able to mark is 4, 0. I'm going to come back over here. 4, 0 is on the x-axis. So that's an x-intercept. We cannot have a y-intercept if there's an asymptote on it. And then we just do our best to draw our curve. Try really hard not to cross the asymptotes. Okay? All right. Number 3, transformation. Well, a 3 on top is going to make a vertical stretch. A -2 on the bottom is going to make a right 2. So if I shift to the right 2, my vertical asymptote should be at x equals 2. And then the -2 at the end is going to shift the whole thing down 2, which means, excuse me, my horizontal asymptote is going to go down to -2. All right, so I should be able to get all of that just by looking at the equation. X equals +2, y equals -2. Okay, so with that, I should also be able to say that my domain is x cannot equal 2, and my range is y cannot equal -2. And everything else I'll get from Desmos. So I'm going to come over here to Desmos, change my top to a 3, put x -2 on the bottom, and then put a -2. And this time I actually do have 2 points that I'm going to cross through. My x-intercept is 3.5, 0, and my y-intercept is 0, -3.5. So I'm going to come back over here, 3.50, 0, -3.5. All right, this is where it would be handy to have Desmos on your phone while you're working on your paper. All right, here's my origin, 1, 2, 3.5, and then origin 1, 2, 3.5. Okay, and so if you remember what the graph looked like, you can flip back to Desmos if you need to. 2 curves or your 2 swooshes. Notice that they're almost always across from each other. That's not going to be the case forever, although most of the ones you see will probably be like that. All right, and last one before I stop this video. Let's see, we've got a -1 at the top, so that's going to be that's going to reflect over the x-axis. I've got a -5 next to the x, so that's going to move my graph right 5, which means my vertical asymptote is going to be at 5. And then the +3 means I'm going to move my graph up 3, so my horizontal asymptote is going to be at y equals 3. And then right away, I can do my domain. I can draw, I can get my asymptotes in there. Make sure your vertical one goes up and down. Your horizontal, find your origin. And it's flat, right? It goes across the page. And then I'm just going to use Desmos to get my intercepts. So one last time over to Desmos right now. Change the top to a -1. The bottom should be x -5. And then out here, I should have a +3. All right, I'll hit the home button. You can definitely still see your 2 curves, and you can get your intercepts. Okay? So on the y-axis, I should go up to 0, 3.2 and put a point. And on the x-axis, I should go over to 5.333 and put a point. Excuse me. All right, so that intercept is right above it, which makes sense since the curve for that piece of the graph and here. And then let's see, 1, 2, 3, 4, 5.333 is just a little bit to the right of this asymptote, And that makes sense since the graph should be on the right of that asymptote. Okay? All right, so we're going to stop there with this video, and then we're going to pick up with a second video on how you graph other rational functions, meaning more complicated rational functions.